Okay, so in this video, we are going to evaluate limits and use different techniques. Primarily, we're going to evaluate limits using algebra. Okay, so whenever you're approaching a problem, a limit problem, you always want to try the easiest thing first. And the easiest thing is always try direct substitution. And if I kind of just eyeball this first problem right here, right? If I plug in -2 in my denominator, I'm going to get 0. And what that tells me is that direct substitution is not going to work, okay? But always try it, plug it in, and see if you get a 0 in the denominator. If you don't, most likely you'll get some kind of number, and you can just be done with the problem and move on, okay? But clearly, if I plug in -2, right, it's going to make my denominator 0, which is not going to work. It doesn't mean the answer is undefined, and it doesn't mean the answer is 0. It just means you can't use direct substitution, okay? So if direct substitution doesn't work, right, you're going to have to use the technique of factoring. So one of the techniques, right, is factoring. And you're based on your studying and knowledge of rational functions and your algebra skills, right? You know you can factor this problem. Well, how do I factor this problem? Recall, right? This is basically a pattern of difference of two cubes, right? A cubed minus B cubed is equal to A minus B times A squared plus AB plus B squared. Okay, so this is a pattern that I keep going back to. You learned it the first time in Math 3. All right, so when you do this problem, right, a couple things about notation. I will be picky. You have to write the limit as x approaches -2. And a lot of times students neglect writing this because they get lazy, but the only time I'll show you at the end when you can not write this is when you substitute at the end. Okay, so you have to keep writing this during the whole time as you simplify. Okay, so I'm going to show you all the steps, right? I can rewrite x to the 6. This is a perfect cube, right? I can rewrite it as x squared quantity cubed, right? Minus 4 quantity cubed all over x plus 2. And this is basically my a value now. This is my b value. And when I plug it into the formula, again, I'm going to write the limit as x approaches -2 of x squared minus 4, right? And then a squared plus ab plus b squared. So I have to square the a, so that becomes x to the 4th plus 4x squared. And then I square this last term, which is my b. 4 squared is just 16. Okay, so now I factored it correctly. I have an x plus 2 over here. Okay, so the goal is to keep simplifying until when you plug in the -2 into your expression such that you don't have a 0 in the denominator anymore. Right now, if I plug in -2, right, I'm still going to have a 0 in the denominator. That didn't really do anything. But clearly, you know that x squared minus 4, I'm not going to use an extra line, is difference of 2 squares. So this factors into this, right? And so the x plus 2's are going to cancel out over here. And what you're left with, the limit as x approaches -2, right, the x plus 2's cancel out, you're left with an x minus 2 of x to the 4th plus 4x squared plus 16. Okay, now, right, if you plug in -2 into this expression, you're going to get a undefined answer, right? There's no 0 in the denominator that you have to worry about, or such that this value is going to make it into 0. And you can just use direct substitution. So from this line, right, you can use direct substitution. You don't have to write the limit sign anymore, or the limit symbol. And you can just show the plug-in. -2 minus 2, -2 to the 4th, plus 4 times -2 squared, plus 16. Okay, so when you multiply this out, you're going to get I believe -192. Okay, so notice how I wrote the limit as x approaches -2 every single time, every single line, until this last step when I plugged in the value. And that's really that's really when you know you can stop and you can use direct substitution, is when no longer you have a 0 in the denominator when you plug in this value. Okay, So one of the techniques is factoring, right? So factoring is very critical. I suggest you really have this memorized, sum of two cubes as well, because factoring is absolutely critical, okay? All right, so factoring is a technique. Take a look at this one, right? Again, if you use direct substitution right here, you're clearly going to get 0, and it doesn't mean the answer is undefined. It just means I have to manipulate. So previously, whenever you learned multiplying by the conjugate in the numerator, right? But you can also multiply the conjugate in the denominator when you see a radical. So the conjugate of this, right, is square root of 2 plus h plus the square root of 2. Okay, so this would be the conjugate of this. And whatever I multiply the top by, I'm going to multiply the bottom by. All right, so make sure you put this in parentheses to help you visualize when you FOIL this. So in my numerator, right, when I multiply something by its conjugate, it's the pattern of, you know, sum and difference pattern, right? This is a minus b times a plus b. So again, this is all algebra, okay? All calculus is algebra. A squared minus b squared. So again, I'm going to write the limit as h approaches 0 each time until the very end. So if this is a squared minus b squared, a squared, if I square this, that's just 2 plus h, right? And if I minus b squared, this is the b, root 2 squared is just 2. It looks like a b over there, but hopefully you can kind of see that's an h there. Now, when you multiply this, don't FOIL it, okay? Write it as, just move everything over. This is root 2 plus h plus root 2. And the reason why I'm going to move everything over is, right, if you combine your like terms in the numerator, these 2's are going to cancel out. And so what you have right now, right, is h over the square root of 2 plus h plus root 2 times h. And, you know, if you can visualize these 2's disappearing, this h and this h will cancel out. And now you have a nice, this is not him, it should be limit. I was looking at the h there. The limit as h approaches 0 of, now when it cancels out, okay, don't call it 0, right? This is h, this is h. If I divide by h, this is actually a 1. Okay, so a lot of your algebra skills need to be in effect here. Now, I still have a radical in the denominator. It doesn't really matter if I have a radical in the denominator. What really matters is if I plug in whatever this value is into my expression and it makes it 0 in the denominator, then I have to keep going and manipulating. Okay, but right now, if I plug it in, right, I'm no longer going to have a 0 in the denominator. And so this is the part where you can get rid of the limit as h approaches 0 when you directly substitute at the end. You're going to get 1 over 2 root 2, right? That's adding radicals if these are like radicals. And then I would ask you to simplify this, okay? Multiply top and bottom by square root of 2. You'll get square root of 2 times root 2, which is 2. 2 times 2 is 4. So your final answer is root 2 over 4, okay? And, you know, just for this problem, right, if you were to graph this, I honestly don't know what this looks like without using a graphing calculator or Desmos. It would look something like this. Let's say this is 1, and let's say this is negative 2. Your graph's going to look something like this. Okay, and then this is taken right from Desmos, okay? So this is approximately root 2 over 4. I think it's 0.3 something. Let me enter this on my calculator. Square root of 2 divided by 4, that's 0.35, okay, 0.35. So this value right here, if you look on the graph, this is approximately 0.353, okay? So again, this value is undefined. The limit as x approaches, or sorry, in this case is h, right, but we'll call it x. From the left side is going to 0.353. From the right side is going to 0.353, or root 2 over 4, right? This is exactly root 2 over 4. So this is what it looks like on the graph, but we did this problem algebraically, okay? So again, you need to make the connection graphically, also algebraically for limits. All right, so that was a technique of multiplying by conjugate conjugate in the numerator. Let's finish up these last two problems on this first page. You have a complex fraction. And again, right, I told you complex fraction skills are absolutely critical. By now, hopefully you know what to do, right? Again, always try to use direct substitution, right? Clearly, it's going to make my denominator 0, which means I have to manipulate, okay? So in a complex fraction, right, you multiply everything by the LCD of the denominators. So the LCD of 8, x minus 8, and 1 is just 8x times x minus 8. So multiply top and bottom by the LCD of 3 denominators right here. This is technically a 1, right? And then start simplifying until you no longer get a 0 in the denominator when you substitute whatever this value is, okay? All right, so when this times this, the x minus 8s are going to cancel out. I'm going to have an 8x. These 8s are going to disappear. I'm going to have an x times x minus 8. And over here, right, I'm going to get a, oh, I'm sorry, this should not be 8x times x minus 8. I misread it. This is a 1, right? The LCD should just be 8 times x minus 8. Okay, so the LCD of 1, x minus 8, and 8 is just 8 times x minus 8. Okay, so when you distribute, right, the x minus 8s will cancel out. And you're just left with a simple 8. When you multiply over here, this times this, the 8s will cancel out. And you're left with an x minus 8. And if you distribute here, you're going to get 8x times x minus 8. Okay, so complex fraction, I mistakenly thought the denominator here was an x. In fact, it's just a 1. Okay. All right, now these guys are going to cancel out, right? 8 minus 8 is just 0. These x's will also disappear. And what I'm left with is the limit as h approaches 0 of 1 over 8 times x minus 8. Okay? Now, if you plug in h as 0, actually, this is a little typo. Actually, this should be an x right here. This should be an x. There should be an x. Okay? These numbers, or these variables, should match. If you plug in 0, you're not going to get a 0 in the denominator. In fact, you're going to get a nice number, right? You're going to get negative 1 over 64. So the limit as h approaches 0 of 1 over x minus 8 plus 1 over 8 over x is equal to negative 1 over 64. Okay, so this one is just using a complex fraction, and again, multiplied by the LCD of your denominators. I apologize for making that mistake of including the x over here. You shouldn't include it. The denominator here is a 1. Okay. All right, so let's move on to this last problem here. And whenever you see a radical, right, you can always think about multiplying by the conjugate. But before we even do that, right, let's plug in 4 over here. If we eyeball it, 4 is going to be over here. 4 minus, if I plug in 4 over here, I'm going to get 12. 12 plus 4 is 16. The square root of 16 is 4. 4 minus 4 is 0. So if I use direct substitution to see if I can get an easy answer right away, it's not going to work. So I have to multiply by the conjugate of the denominator, which is x plus the square root of 3x plus 4. X plus the square root of 3x plus 4. Okay, put this in parentheses. All right, now there is, this problem is looking really, really messy, but there is a little bit of a trick. And my trick is that when you FOIL this, right, don't FOIL it right away, right? I mean, you could distribute the 4, distribute the negative x, combine them. I would just leave it as a factor, because later on you're going to have to cancel something anyways. So don't multiply it right away. Okay, so what I mean is rewrite this line, limit as x approaches 4. Just copy that line over again. But I'm going to simplify my denominator, right? This is my a, this is my b, this is my a, this is my b. Okay, when you multiply an expression by its conjugate, it's just a squared minus b squared. Okay, so a squared minus b squared, right? If I square this, right, this is a squared minus b squared. That's just x squared. subtract my b squared. If I square the b, right, the square root of 3x plus 4, this whole thing's my b, is just 3x plus 4. Now be careful, put this in parentheses, right? If I square this, it's just 3x plus 4. Okay, now, copy that line one more time, or the numerator, I should say. I'm not going to use an extra line, okay? So if you distribute right here, right, you're going to get x squared minus 3x minus 4. Now take a look, right? This line right here, it's perfectly nice and factorable. This is this new denominator is perfectly nice and factorable. It's x minus 4 times x plus 1, right? Now take a look at these two terms, right? They're almost the same, but not quite. Use the -1 technique. Basically, factor out a negative right here, right? Now take a look, right? These terms will cancel out. I didn't even need a FOIL. You could put the negative at the bar right here. And now if I use direct substitution, right, I'm actually going to get a number that's not going to make a 0 in the denominator, okay? So finish up this problem right here. There should be -4 plus the square root of 12 plus 4, right, which is 16 over 4 plus 1, which is 5. Square root of 16 right here is going to give me 4. And actually, I got a little bit sloppy here. This negative should be right at the bar. Square root of 16 is 4. 4 plus 4 is 8. So your final answer is -8 over 5. All right, so what I want to stay on this problem is, you know, using the technique of multiplying by the conjugate in the denominator is really the technique to do this problem. But just be careful here. Sometimes you don't need a FOIL. Sometimes you do, okay? In this particular problem, right, for me to cancel out these terms, I needed to recognize that, hey, after I distribute my minus sign, I get this, which is nice and factorable to this. And these two terms just differ by a single minus sign. So I used the -1 technique, factor out a -1. And then I got almost a little bit careless right here, right? Make sure you put the negative at the bar. If you put it up here, right, you might think, oh, it's -4 plus 4 is 0. 0 divided by 5 is 0. That's not quite right, okay? So make sure you put this in parentheses here, and you won't make that mistake. Okay, so final answer is -8/5.